hybrid analyzer for web application security. Mr. Lavakumar is the author of IMAX, the advanced web security testing platform. He has also authored multiple other security tools like Cell of the Future, JS Recon, Imposter, and HTML5-based distributed command system. Ravan. As a security researcher, he has discovered several novel attacks that included a sandbox bypass on FlashFire, web bypass technique using HTTP parameter pollution, multiple HTML5 attacks, and a CSRF protection bypass technique using kickjacking and HTTP, which was voted by peers and experts as the fifth best web security hack of 2010. His work has been covered by leading media portals, including the Forbes. I request Mr. Lavakumar to take over the stage. Thank you.
Hello everybody. My talk is titled HAWAS, and before you get any ideas, it is only related to web application security. So if you had anything else, and if you are expecting something else, I'm sorry to disappoint you. It's going to be a pretty clean and plain talk, so nothing to worry about. Okay, so I'll skip my introduction because it's just a 30-minute talk, and if you want to know about me, probably you can get hold of me after the talk. Now, just to get a feel of the audience, how many of you here do web application pen testing or are related to web application security? Yeah, so that's like pretty much all the audience. Right, when you do web application pen testing, there are some sections of the test that you can actually automate. And when you look at it, usually the part of the test that gets automated is checking for SQL injection or checking for cross-site scripting. It's usually the fuzzing part and the scan part that the tools automate. But then pen testing is not just this. There's a whole lot more to pen testing. These other checks are usually done manually. And if you have a big site which has probably over 1,000 pages, then manually doing all of these checks on all of those pages is not just time consuming, but it is extremely insulting to the pen tester's intelligence, right? Because the pen tester is not a dumb guy who's trying to do something which is low risk, right? It's not an activity which is meant to have repeated actions of the same thing going on again and again. Pen testers basically need something by which they can, once they have an idea in their head as to, okay, this is what I'm going to check for, so they must have methods by which they can automate it, and then they can look at the result, and then try to infer if something interesting is there inside or not, right? And these other kind of checks, like checking for CSRF and access control violations, hidden parameter guessing. Anybody here does hidden parameter guessing in their pen test? Yeah. Okay, that's hardly 1 or 2% of the audience, right? Nobody does this. It's a very simple check to do technically, right? But nobody does it because it's extremely hard to do. It's time consuming and it is boring, And pen testers are usually a little creative, so anytime they have to do repeated stuff, they kind of get bored, right? Somebody once said in a talk, not a security talk, that if you do something once, you are a scientist. If you do it twice, you are an engineer, and if you do it more than 3 times, you become a technician, right? So pen testers do not want to be technicians, right? And the other part is coming up with site-specific attack vectors, right? And this you only do when you analyze the application and you understand how the application is designed, right? What are the different parameters? What are the different values? And once you get a good understanding of what the site is, what the flow is like, then you can come up with customized attack vectors which are specific to the site. Something. That's where pen tester actually adds value. Now, HAWAS is a utility, or rather a tool, which helps you perform these, checks like CSRF, access control, hidden parameter guessing in a fairly semi-automated way. And it also does some amount of analysis and gives you information about a website, which will help you in performing site-specific attacks. That is in understanding the application's design a little better and then coming up with custom attack vectors. Right. Now, when you look at understanding the application, the first thing any pen tester would do is he'll probably set his favorite tool as a proxy, in his browser, and he'll browse through the site. Right? He'll crawl the entire site manually. He'll build up a sidecar listed out a bunch of parameter names, and you can see there are two parameter names that look interesting: logged in and inserted. Right? So if the site has a parameter name called as log_in, and if that value is 1, then you could check for authentication bypass. Without even being logged in, you could say logged in is equal to 1, and you could try to see if the application lets you go inside. Same thing for is_admin, right? So even if you're not an admin, you could set the parameter is_admin is equal to 1 or is equal to true, and you could see if you can do a vertical privilege escalation, right? So looking at the list of parameters, there could be so many other interesting names depending on the kind of application you're testing, but listing the parameter names makes it very easy for you to identify these interesting parameters. And the other thing is listing out the parameter values. Now, in a site which has 1,000 pages, if there are thousands, let's say there are 3,000 parameter names, then the parameter values would be exponentially higher. Maybe there would be more than 1 lakh different parameter values. And some of those values could actually be quite interesting. For example, if you look at the list here, you could see there is a filing, there's a PDF filing that's being passed as a parameter value. If you could look, if you spot this, then you would normally check this for a local file include or some kind of directory traversal vulnerability, right? And similarly, if you see a URL being passed as a parameter value, then you could check this for remote file include. You could check this for open redirect vulnerabilities. And sometimes you could, like the last case, there could actually be an actual SQL query which gets passed as a parameter value. And I've seen this in actual real world sites where the SQL query is created on the client side in JavaScript. The entire query is sent to the server side, and the server simply runs the SQL query and gives the response back. Now, the weird part about this is, if you were to do an automated scan on this parameter, which simply takes a complete SQL query as an input, then it is very likely that the automated tool might not detect this. Because I've written a web application vulnerability scan myself. I know how the algorithms are written. And these kind of inputs people are usually not expecting. So something like this might even be missed by your automated scanner when it's checking for SQL injection. But when you're manually looking at the parameter values, right, you could probably detect something like this. Any kind of interesting pattern that's available, when it is listed out to you, when it is easy for you to consume, you can identify these patterns. Now, let me show you where HAWAS comes in, right? Now, HAWAS is a module that I've written for HAWAS. HAWAS is a tool that I've written for web application security testing. And let's start this module. Right. So what I've done is I've browsed through a site. The site is demo.testfire.net, which is a test site available with some existing vulnerabilities. I've browsed through the site, which any pen tester would normally do. And then I start my analysis. So what HAWAS is doing is it is going through all my logs, and it is analyzing them, and it is creating a mapping of all the parameter names and values. So it's done, and when I look at the results, it shows me all the different hosts which were identified in the log. And if I select a particular host, it gives me all the parameter values which were there under that particular hosting. I could say select a specific parameter. So I want to look for this ASP session ID. Then it tells me all the different values, all the different sections in which this parameter occurred. So for example, this parameter was discovered in the setCookie section of the response and also in the cookie section of the request, right? And you could select a specific section and it will tell you all the values that this parameter had in that section, right? So this makes it, and if you click on a specific value, it will give you it will print the whole value, and it will also tell you in which log IDs this value actually occurred, right? So you can go to the log ID and you could look at this for better information. So when you take this and you compare it with what I was discussing a little earlier, where you can look at parameter names and values to identify interesting patterns, this makes it very easy for you to do that, right? So you can drill down based on a specific parameter and you can look for its values. Right, so this is the base with which you could start. start, right? But then it does a lot of other interesting things as well. Right. One thing is identifying encoded values. Now, base64 encoding and hex encoding is very common in web applications, right? So sometimes the application could encode a certain data in either base64 or hex, and that could be available on the client side. And this value could have been transferred in between the browser and the server in an encoded format. But then when you normally look at it, it might have some sensitive information, but when you normally look at it, you wouldn't make out that it is encoded or if it has any sensitive data inside it. For example, you look at these bunch of strings. Do you see anything interesting in them? For example, if you are doing a pen test, and if these were the list of parameter values that you saw, right? Would you be, would you like go and probe any further on any of these? Probably not, because they all look like random junk and they don't seem to indicate much. But then, two of these are actually encoded values. So this one is a base64 encoded value, and if you want to decode it, it is Lava : secret 123, right? And the other one is hex encoded, and it has discount 21%. So when it's in a decoded form, you can actually see that it has some, right? So you can go there and you can look for more details. Right, so any questions so far? No, please.
Not a question, suggestion. If you could provide the hyperlinks or button for the proxy values and the parameters, it will help us in side by side doing it.
Yeah, it actually would, but programmatically it's kind of difficult to do, but I'll try to see what I can. But for now, we could just probably have them side by side and go. Yeah, that's a good suggestion. Thanks. Okay, so this was identifying if a parameter is encoded or if a parameter is hash and tracking the hash. Right? Now, as pen testers, I'm pretty sure all of you check for cross-site scripting vulnerabilities when you're doing a pen test, right? But how many times have you identified stored excesses on your web application? What would be the percent of stored excesses versus reflected excesses vulnerabilities you have identified in your entire career? Can somebody give me like a figure? Let's say you have reported 1,000 excesses vulnerabilities in your entire career. How much of those are stored excesses?
Less than 10.
Sorry?
Less than 10.
Less than 10, right? So let's say a developer who does not encode a value which is being reflected back in the same response, right? That's a reflected excess. The request comes in, the response has the same value, right? The developer who fails to do encoding in such an obvious case, do you think he is smart enough to or diligent enough to encode it when the response is being reflected back in a completely unrelated response? Not very likely, right? So, given that case, why do you think the percent of stored excesses discovered is so low? Any guesses? Kind of, yeah, because there are no automated tools to do that, right? And even when you're manually testing them, what you do is you pull up one, log, and then you try to send the request, you put some payload in, send the request again, and you try to see if the response has, the payload being reflected back. The reason why you have not discovered a lot of stored excesses is, sorry to say, you simply are not looking for stored excesses, and the reason you are not doing it is because it is hard to do. When you have a big application, 1,000 pages, you do not know which input you gave because you are giving probably lakhs of input. You don't know which input you gave is being reflected back in which page, right? So unless you know this mapping, you do not even know where to check for the stored excesses, right? So it's a very obvious problem, and it could be solved in a very, very simple way, which I have tried to do also. So there is a section called as potential stored excesses candidate. So what HAWAS does, because it is anyway looking at all the parameter values, it makes a list of all parameter values which was sent in a request, and if that parameter value is reflected back in some other response later on, right? It does this mapping and it highlights this correlation, right? So for example, here when I click on this, it gives me 3 entries which are possible stored excesses candidates, and if I click on one, it tells me the parameter name content, which appeared in log ID 47, got reflected back in log IDs 50, 52, and 55. Right? Now, and what I do is, in these three IDs, I ensure that the request for these IDs did not have this parameter and it did not have this value, so that I don't give you false positives of cases where the value is just being reflected back. Right? So this gives you an indication to go and explore these cases randomly and try to see if this was actually stored information which was being reflected back, and if it was, then you could test it for XSS, and you could probably increase the percent of stored XSS you discover, and that will make your client a little bit more secure, right? Okay, so this was identifying stored XSS candidates. Any questions on this? No? I guess these are all like pretty straightforward technically, right? So these are like obvious things, but why wasn't I doing this earlier? It's kind of like that. But anyway, now, so far whatever you've seen, these are all passive analysis, right? So these are all stuff which is identified passively. Now, if you look at the name of the tool, it says hybrid analyzer for web application security. So I'm not really come to the hybrid part, right? The reason why it's called as hybrid is because it does passive checks, and then it also lets you do some kind of automated and interactive checks, right? So that's why it's called as hybrid. Now, when I started my talk, I was telling you that looking for CSRF and access control checks and hidden parameter guessing. So these are things which take up a lot of effort, right, if you were to do it manually. Now, if you look at these three checks, hidden parameter guessing, CSRF checking, and what was the other one? Access control, right? So all these three have a certain kind of similarity in how you check for it. So what you do is, you have a baseline response. You send a request, you got a baseline response. Let's say, for example, there is a request which has a CSRF token. You send the request, you've got a response back. And if you want to check if it is vulnerable to CSRF, what you will do is, you will either remove the token value, or you will change the token value to something else. You will resend the same request, you will get the response, and you will compare this response with the earlier response. Right? If the responses look similar, it means the token did not have any effect, which means it is vulnerable to CSRF. Right? The same will go for hidden parameter guessing. Like for example, if you want to check if adding a parameter admin is equal to true, if it has an effect on a particular request. So what you do is, you have a baseline request, you will send the same request, but then you will add this new parameter, and when the response comes, you will try to see if this response is different than the earlier response. If it is different, then adding admin is equal to true actually had some kind of effect on the server. If the response is same, then that didn't have any effect, right? Same goes for access control checks. You have a request which has been sent by, let's say, a high privilege user, right? So what you do is, you change the cookie session ID value to that of a low privilege user, you send the same request again, response comes back, you compare the responses. If the response is same, then it means that the low privilege user was also making the same request and get the same response as a high privilege user, right? So that way you can do access control checks. So the similarity is, in all of these cases, you have a baseline request. Now you either add a parameter, you delete a parameter, or you edit a parameter, send the request back again, and when the response comes, you compare this response with the baseline response. And depending on whether they both look similar or they both look different, you can determine if that particular vulnerability exists or it does not exist, right? So given this, workflow, right, you can have one kind of utility which will automate all the steps to it, right? So what I've created is something called as a log analyzer. Now this is still a work in progress. So let's say you have gone through the site again, so you have all the logs available with you. You can select, the request that you do want to check for this kind of, for CSR, for hidden parameter guessing or whatever, and then you can say test selected sessions. And then it'll ask you what kind of test you want to do. You want to add a new parameter, edit an existing parameter, or delete the parameter. Let's say I'll say I want to add a new parameter. And then it'll ask me what is the type of the parameter. I'll say cookie, and I want to add a parameter named admin, and set the parameter value to 1. Okay, now this is the part where I'll be actually making requests to the server, because I'm going to add a parameter resend the request back. So what I'll do is I'll turn on Wi-Fi in my phone so I can get it. For internet connection, what I've done is I've selected the request that I want to test. I've said which parameter I want to add. So now I'll say start test. Right? So what it does is it has the original response code, the original response length, which was there available in the logs. It resends the original request again, and it tells you what is the response code you want and what is the response length. And then it adds the parameter that you selected, sends the request again, and it tells you what is the response code and response length for the final request, where the parameter was added. And then it also does a diff between the original and the test request, and it tells you what is the percent of difference between these responses, right? So 0% basically means there was no difference in the response. If it was 100%, it means the response is completely different. If there was a certain, if 20% of the response was different, then it would say 20%, right? So you could like pick 100 requests from your log, and you could say, if you want to do hidden parameter testing, you could say add admin is equal to true. You could start the test, and so you will see 100 entries here, and simply by looking at the diff levels, you will know if any of them had any kind of impact. And if there was some difference, let's say, and if you want to analyze it still further, so you can click on a particular entry, and it will show you what is the original request and response, which was available in the logs, the request and response which was sent back to the recent request and response, and this is the final one. If you look at this is the URL, and if you look at the test one, you can actually see it has the parameter admin is equal to 1 added. This was the parameter that we wanted to add and we wanted to test for hidden parameter testing. And then it also does a diff between these things, and it gives you a nice comparison view. In this case, there is no difference. If you look at the response, the only difference is in the server time because they were both sent at different times. But then if actually this vulnerability did exist, you will see some sections of the responses being different, and that will be highlighted to you, right? So you don't have to like go to 2-3 different tools to even look at the difference. All the difference is automatically done for you, and so here in this case the request is there's a difference in the request because the parameter was added at the new one, and again you can look at the response diff, and you could find out what part of the response changed, and if adding this parameter had any kind of impact, right? Okay, so that was the interactive testing part of the tool, and that's why it's hybrid, and hence the name, right? Okay, so that was it. I am probably the only speaker who has completed my talk before time, to the relief of the audience. And thanks in a large part to the largely silent audience. That's just a joke. Anyway. Yeah, so now that we are done, I'll be happy to take questions.
And like parameter setting we have done for get request, adding parameter to the URL. So is it available for a post request also?
Oh yeah, you can select different types of parameters, body parameter, cookie parameter, header parameter, cookie and header you would normally not use, but if you want to, you can do that as well. And then there is something called as URL path, right? Normally when a lot of applications use URL rewriting, right? So the actual URL path would be a parameter name, right? So a lot of times you would want to test that also. So you could say URL path part, and you could say the first part or the second part, right? And then that part will be updated. So any part of the request can be edited this way. Right? Any other questions?
Is there a possibility to extend the stuff? So that we have been doing this, the comparisons between the parameter values and the parameter names, and
JPEG.
Okay, right.
So, like, you are listing that. Now, the application will give you a list of all the inputs which are going to the application, irrespective of whatever. So, what my suggestion would be like, you should have an option which will pass malform objects. That means these file objects have a lot of metadata which are read by the author's name.
Right.
A lot of application reads metadata from this application. So you should have a set of custom built file objects, and then which is like which the author's name is tampered to a script alert, or the file name is tampered to a script alert.
Right.
And then you should automatically pass these malformed objects to the application and just check for the response. None of the applications auditing tools have this sort of facility.
That's a pretty cool idea, and you know what? In fact, discussing it will be better if we do it face to face, because this will, I think, it will be a pretty technical discussion.
I just got it right now with you.
Yeah, that's a very good idea, very good suggestion. So, in fact, any other suggestions that people have, you could just hit me up, and either I code it in, or if you're good enough, you can code it in, and you can code it and put it on the original one. And I'm out of time, so if you have any questions, you could probably get a hold of me outside, and we could discuss this. Right? Alright, so thanks a lot for listening patiently, and hopefully your further debate is full of HAWAS. Alright, thanks.
Thank you, Mr. Lavakumar, for sharing your knowledge with us. I request one of our ClubHack team to give a token of appreciation to Mr. Lavakumar.